Okay, so that's one use case for a class attribute, keeping track of things, sort of like analytics, if you will, about the individual instances of the classes, like how many have been made, the average of something across all of them. Now, another common use case would be to actually create validations. So let me show you what I mean. Okay, so I made a new file called pet.py. And the idea here, we're going to make a pet class that each pet has a name and a species instance attribute. So name could be Fluffy, species could be dog. But we're not going to stop there. We're actually going to create a list of permitted species for pets. So we're not going to allow someone to have, a 3-headed dog as a pet, or a crocodile, or a lion or something. So we're just going to create a class attribute that's going to store the list of permitted species. But let's start by just doing class pet. We'll define our simple init. Self is first, then let's go with name and species, just like this. And let's just do self.name equals name, self.species equals species. Kind of boilerplate-ish in our initialize method. And we can just begin by doing, cat equals pet, and name will be blue, species will be cat. And then we'll do one more, and it will be a dog. Dog will be called Wyatt, and species is dog. All right, so this is all review. Now the thing is, I don't want to allow someone to do pet Fluffy is a tiger, for example. And to prevent that, I'll create a class attribute called, let's go with allowed. And in here, we'll just put in things like cat, dog, fish, and let's do rat as well. I apologize if your favorite pet is not here. Just for the sake of keeping this brief, I'm not going to add in every possible pet. Okay, so these are the allowed pets. And this could be a class attribute. Well, it will be in our example, but it actually doesn't have to be. I'll talk about when you would make something a class attribute versus when you would just move it into init. But for now, let's just keep it as a class attribute called allowed. And all we'll do in here is add a little check. If species not in allowed, and I can't just reference allowed, I need to reference pet.allowed, or alternatively, this is something we haven't seen, I can actually use self.allowed, which is the syntax we use for an instance attribute. I will come back to that, but let's leave it at pet.allowed. So if species is not in pet.allowed, let's raise a value error and just have an F string in there that says something like you can't have a, and then let's add the species in pet. All right, you can't have a crocodile pet. You can't have a grizzly bear pet. Okay, otherwise, we'll just add name and species as instance attributes. So at this point, I'll copy this over, move to my terminal, open up Python 3, and I make a new pet. Let's go with Tony, and Tony is a tiger. That's not in allowed. So I get value error, you can't have a tiger pet. But if I just do pet, let's do a variable c equals pet, and it will be blue again, which is a cat. C works just fine. Okay, so we have a class attribute allowed. Now the question you might have, this is a perfectly valid question, is why does that need to be a class attribute? We're only using it inside of this init method. We could just move it in here into the init method and just change this to be in allowed. This is not a class attribute. This is not an instance attribute either. This is just part of the init method. It exists in that scope. If I just copy it over and paste everything, if I look at cat, or let's try doing pet.allowed, it's no longer defined because it's not a class attribute, but I also can't do cat.allowed either, or dog.allowed. It only exists in this method. And if possible, you want that to happen. If you don't need access to this in any other method, you're only using it in init, put it here. However, let's say that I wanted to also prevent a user from changing dog.species manually, because right now there's nothing stopping someone from doing dog.species equals tiger and just overriding the species property after we initialize. As you can see here, I have dog I could do dog.species equals whatever I want. Tiger, no problem. And technically, we don't really have a way to officially prevent that, but what we could do is create a method, and that method could be def change, or the standard would be to call it set species, and then it should take in species, and also we need self. And then all that we would do here is set self.species equals species, but we want to do the exact same thing where we check if it's allowed. So rather than copying allowed over here again, we're defining allowed twice, not to mention the fact that what if, we change allowed, we add a species in there, or we remove a species. We don't want to have two copies. So we can make a single copy, the class attribute, go back to that, and then change this to be pet.allowed. And then here, we don't need to redefine it. And we just do our if, and I'll just copy this exact same thing. I missed the I at the beginning, but now we have our same check. If species not in pet.allowed, raise the same error, and then otherwise set species to be the new species. Paste everything. Now if I look at cat.species, it's cat, but I could change it using cat.setSpecies, and the new species, if I try and set it to tiger, I get an error. But if I try and change it to rodent, or what do we have, rat, that works. And now if I look at cat.species, it's rat. And so then we have pet.allowed is still cat, dog, fish, and rat. Now here's the cool thing. I mean, cool is an overstatement, but here's the thing that I can do. If I add something to allowed, pet.allowed, and I do a .append, what would be a new species that it's allowed? How about hamster? How about, okay, pig. There we go. So now if I look at pet.allowed, it contains pig, and I don't have to update anything in order for my cat.setSpecies to work. I can now set it to pig. Because we set allowed as a class attribute, when I updated it, all of our pet instances, the individual objects, know that pet.allowed is now one thing longer, it contains pig. And so now I can set cat.species to be pig, which makes absolutely no sense, but cat is now a pig. So here's a little diagram I threw together. It's kind of messy, but it shows what's happening. So we have the pet class with a single class attribute called allowed. In this case, just to make it fit in this block, I only added dog and cat. Then we have each pet instance. This first one has a name, an instance attribute called name set to Fluffy, instance attribute called species set to dog, and then it has this thing called allowed, but it's actually pointing to the pet class attribute allowed. Same thing over here. So when I say that it has an attribute called allowed on the instance, that's technically true, but it's only referring to the same pet class attribute. It's a very kind of difficult thing to talk about, but let me show you with concrete memory address proof that they are pointing to the same pet class allowed. Okay, so we have two pets. We have cat, and cat has a name, which is Blue, and then we have dog, another instance of pet, and dog has a name, which is Wyatt. So they have their own individual copies of name. They are instance attributes. And then we saw pet.allowed, which is a class attribute. But the thing is that cat actually has its own attribute called allowed, and dog has an attribute called allowed as well. And they are not unique individual copies. And to prove to you what I'm talking about, there's this function called ID we haven't really seen before. But if I run cat.allowed, this is going to give me like the unique ID that Python assigns to things. So look at this number here. Don't memorize it or anything, but I'm going to do the same thing with dog.allowed. Okay? And they are identical. And one more thing, if I change it to pet.allowed, they are all the same. So what this shows us is that cat.allowed, dog.allowed, pet.allowed they all refer to the exact same pet class attribute. There's only one allowed attribute, even though, and it's kind of weird, and this is something that's somewhat unique to Python, at least compared to some of the other languages I've worked with personally, where the actual instances still can access allowed You don't have to go through capital P pet. You can go through the instance, but this is just a reference to pet.allowed, hence the little arrow here. And that does mean that inside of our class, I could create the class attribute allowed and refer to it using self.allowed like this instead of pet.allowed. I prefer to do pet.allowed. It makes it very clear this is a class attribute, but self would work here as long as we're not updating or assigning a value to self.allowed. We're just accessing it. It's going to access pet.allowed. But the moment I do something like this, so we have pet.allowed already, this list, and we have cat.allowed. If I changed cat.allowed to now be a list that just contains tiger and bear, like this, and I look at cat.allowed, it's now tiger and bear. And if I look at pet.allowed, they're not the same thing anymore. So what I've done is actually made an instance attribute called allowed and set it to this only on cat. So dog.allowed is still referring to the class attribute. Oh, I am worried about this explanation. It's kind of a lot. I'm saying allowed a lot. It really doesn't seem like a real word to me anymore. Repeated it too much. But hopefully this right here helps illustrate my point that the individual instances are referring to the pet attribute on the pet class, and that when we set cat.allowed to tiger and bear, we overrode this arrow. We kind of severed this connection and we gave cat its own version of allowed, but dog is still pointing to the pet class. To summarize everything we've seen in this video, there's been a lot. Class attributes exist on the class. You can use them for things like keeping track of analytics or a count of how many instances have been created. You can use them for things like validations, as we've seen here. However, if we were only using this once when a new pet was initialized, it would be better to not make it a class attribute. Just put it in this method and it goes away after the method is done, just like any other method or function we've defined. But because we wanted to use it more than once, we used it down here as well. And on top of that, we don't need a unique version of this in every single instance of pet. We made it a class variable that exists once. Okay, this is kind of long. I apologize for that. There's a lot to talk about here. Next up, you're going to get more practice defining your own another class and another class with a class attribute.